Alright, let's look at the higher derivatives. Right, so it's mostly notation. Higher derivative simply means that you take derivative multiple times. Alright, so here's the notation. If you start with the original function y equals f of x, first derivative is of course y prime and f prime. Right? There's a slightly different notation. We can also use this notation. We can do dy over dx. So it's basically the d stands for the derivative of y with respect to x. Right? So with respect to just means that you look at that as a function and specifying the variable. So you're looking at y as a function of x, then we take the derivative, right? And then second derivative is just a derivative of the first derivative. So you can do y prime, double prime, or f double prime, or we can do put the derivative. So you put actually two right here, y over dx2, right? You might think that this looks a little bit of a strange notation, but this makes sense because we take the derivative. So here's the first derivative. Then we take another derivative. So we put the d over dx here, right? So treat it like multiplication between fraction. You have two of these multiplied together, d squared. You have two dx's multiplied together, dx. So that's the notation for the second derivative. And you can easily guess what the third derivative is. So d3y over dx3, right? All right, so the fourth derivative is a little bit tricky because if you keep on putting primes, it's going to be very difficult to read, especially if you go beyond 3, right? Third derivative, triple prime is fine, but once you get to the fourth derivative, we typically do not put the full primes. So we put a number of derivatives in the parentheses. So y, so don't forget to put the parentheses, because if you don't, then it means that it's a fourth power, which is completely different. So if you want the fourth derivative, you put the y to the, put in the parentheses 4. Right? So this is the fourth derivative, same y. And the other notation, it's nothing is different. You just change the numbers here. Right? So that's the fourth derivative. All right. And if you're talking about, say, velocity, actually the position function, let's say original function was a position function, right? If you take the derivative of that, so it tells you, so it's a function representing how fast the position is changing, right? We know what it's called, right? It's called the velocity. All right. So if you take another derivative, so second derivative, then this tells you how fast the velocity is changing. So this is the acceleration, if I can spell that word, acceleration. I think it's spelled that way, right? Acceleration, right? Then if you look at the third derivative, we don't hardly talk about it, but this tells you how fast the acceleration is changing. I guess it's called jerk. Right? I don't know the fourth derivative, but let's stop there. So if the original function is a position function, its first derivative is velocity, second derivative is acceleration, and the third derivative is called jerk. Right? So let's look at the graphs of derivatives and see if we can sketch the ballpark picture of what the derivatives will look like. All right, so let's start with this kind of like a double shape graph, original function f of x. All right, remember that derivative tells you about the slope of the tangent line. So easy place to look first would be places where you have a horizontal tangent line. So like here, you have a horizontal tangent line, and here you have a horizontal tangent line. here we have a horizontal tangent line. So what you can do is you can actually just indicate those points. So here you are supposed to have a horizontal tangent line. Here, same way, horizontal tangent line and the horizontal tangent line, right? Horizontal means that the slope is 0, so its derivative must be 0 there. So which means that it actually goes through x-axis. So this point here, that point there, that point there. Right? And next one, it tells you about the slope. So here, it's coming down, which means that it's negative, which means that the derivative is below the x-axis. Here, it's going up, so derivative is positive, so go above. Here, it's going down, so it's go below. And here, going up, it goes above. So if you sketch that, so you're going to have to start, since it's coming down, so you have to start from the below x-axis, and hit x there, and becomes positive because increasing here, and then decreasing again, and after that it's increasing. Alright, so this is the graph of f prime. Alright, can you sketch the graph of f double prime? Alright, so let's try that. Alright, so look for the horizontal tangent line here, and there's going to be a horizontal tangent line there. So we can go from there. So you can just mark that point here and mark that point there. All right, so let's use a different color. Let's try, so how about this, red. So we have to go through this point right here, and we have to go through the x-axis at that point. All right, so in the beginning, f prime is increasing, so f double prime has to be positive. So you're going to start out positive. All right, after that point, it's decreasing, so which means that the second derivative is negative. And then you come back, and after that, it's positive. So you have like a parabola looking shape. This is your our f double prime. All right, I'll just do one more, just for the heck of it. All right, so let's see. Look for the horizontal tangent line. So right here. All right. Then you're gonna just try to mark it. It's probably right around there, and I'm gonna have to use another different color. Let's do brown. All right. So it's gonna go here. All right. Here's a brown dot there. All right. Here. Right, so we know that here in the beginning it's decreasing, so coming down. After that point it's increasing, so it's going to turn from negative side to positive side. So it probably looks somewhat like that. Alright, so that is our third derivative. Right? So if you want to sketch the graph of the derivative, first thing to look for is the horizontal tangent line, because that will be the x-intercepts of the derivative. Then you look at the increasing decreasing behavior. If it's increasing, derivative should be positive. If it's decreasing, the derivative should be negative. Then you can sketch the ballpark pictures of the derivatives. Right? That's it. I hope that this was clear.